In this video, I am going to discuss two-dimensional geometric transformations with matrices. There are many types of geometric transformations, but in this video, I limit my discussion to these three: translation, scaling, and rotation. So first, let's look at translation. In order to understand this, let's consider these are the two axes, x and y. Here we have the origin. We have a point here. Its coordinates are x comma y. So here we have x and here we have y. Now, if we move this point to somewhere here, and coordinates are x1 comma y1. Now, therefore, here we have x1, here we have y1. Now, we move this point to here. So, let's take this difference as tx and this difference as ty. So x1 equals x plus tx, then x plus tx, then y1 equals y plus ty. Now, let's represent coordinates of this point like this from a matrix. Here we have two rows and one column. This point also we can represent using a matrix. Here also we have two rows and one column. Now we have this 2 cross 1. We have this matrix, and then let's say here we have x1 y1, 2 cross 1. We need to find a matrix that can transform this matrix to this. That means, in other words, if we multiply these two matrices, we should get this matrix. Now, in order to do that, let's think about these two matrices. In order to be able to multiply these two matrices, here it should be something like this. That means the number of, here it should be something like this. That means number of columns in this matrix must be equal to the number of rows of this matrix. Therefore, here we have 2 rows. Therefore, here we must have 2 columns. And now, this is the answer of this multiplication. In the resultant matrix, it has 2 rows. Therefore, here it should be 2. Now, this is a 2 by 2 matrix. We have 4 values. Now can we find 4 values for this matrix so that we get this one? That means let's write this one. You can write this as x plus dx. X1 means x plus dx and y1 means y plus dy. This is also 2 cross 1 matrix. Now in order to get this, can we find 2 values? So in order to find x plus tx, so here you have to find 2 values that can make this one. But you cannot do that. Even if you put, let's say, even if you put, you can get x. If you put 1, 0 here, you can get x. But how can you get this term? You cannot get this term. Therefore, this transformation we cannot do in this way. Using a 2 cross 2 matrix, you cannot do this. Therefore, we need to find another way. Let's say instead of representing using a 2 cross 1 matrix, now we represent in this way. 3 cross 1. We represent the coordinate like this. We put 1 here. And then this matrix, this coordinate, we can write down it as y1 1. 3 cross 1. So now we have x1 1. This one is here. 3 cross 1. We need to find the matrix. Finally, we get x1 y1 1. This is 3 cross 1. Also, here now we can write this like x1 means x plus dx. y1 means y plus dy. Here it is 1. This is also 3 cross 1. Now here, in order to be able to multiply, here it should be 3 cross 3. Something cross 3. So in the resultant matrix, this is 3. The number of rows is 3, therefore here it must be 3. Now it is a 3 by 3 matrix. We have to find its elements. It is a 3 by 3 matrix. Now here, here, here. So in order to get x plus dx, so here if you put 1 into x, we can get x term. Then here we do not have any y term, therefore we have to put here 0. Now in order to get dx, if we put here dx, you get dx. Now if you multiply this row by this column, then you get this element x, this one 0, dx, you get this. So similarly you can write down the second term we do not have x terms, therefore here we have 0 and y, finally ty. So 0 y plus ty, y plus ty. Finally we have to get 1. Therefore no x terms, no y terms, 1 into 1, 1. Therefore now we could find a matrix that transforms this to this. Therefore actually that is why we use this additional value. Here we have taken it as 1. Now this matrix, we represent this matrix like this: t, tx, comma ty, 1, 0 tx, 0, 1 ty, 0, 0, 1. This matrix is called the translation matrix. That is about translation, and then we have to move to scaling. Scaling. So again let's draw the two axes. Here we have the origin. Now we have a point x comma y. Now we scale, that means we multiply x coordinate by some value, y coordinate by another value. So suppose that you get a point somewhere here and its coordinates are x1 comma y1. x1, here we have y1. So let's take x1 equals sx into x, y1 equals sy into y. That means we have a point, and if x coordinate we multiply by a value sx, then we get x1. Y coordinate, if we multiply it by sy, we get y1. So now let's represent this coordinate like this: 2 cross 1 matrix, 2 cross 1 matrix. So now this one by x1 y1, 2 cross 1. Now we have xy, 2 cross 1 matrix, have to find the matrix so that the multiplication of these two gives x1, y1, 2 cross 1. That means if we substitute x1 and y1 from these two values, you get sx, x, sy, y. So this is now this is 2 cross 1 matrix. Now in order to be able to multiply these two matrices, something cross 2. The type of this matrix must be something cross 2. Resultant matrix has 2 rows, therefore here it must be 2. Now let's try to get this one. Now here we have 4 values. 4 values. So if we put, now we need sx into x. So here we put sx, you get x this term, this row and this column, you get this one. Therefore here it should be 0, and now sy into y, no x terms, therefore here it is 0 and here it is sy. Now we could find a matrix so that when we multiply these two, you will get this. Now this is a scaling matrix, but the problem is when we were talking about translation, we failed to find a 2 by 2 matrix for translation. Therefore, we introduced a trick and found a 3 by 3 transformation matrix. We have to maintain the consistency, and therefore we have to find a scaling matrix also with this type. Okay, we need a scaling matrix with the type equals to this value. The purpose is to maintain consistency, but when you learn geometric transformations further, you will realize the real purpose. Therefore, now as in earlier situation, let's represent x, y, 1. Coordinates of this point we represent using 3 cross 1 matrix. We put a 1 here as in previous situation. So here we have a matrix. Finally, you should get x1, y1, 1, 3 cross 1. So if we substitute these two values here, sx, x, sy, y, 1. This is 3 cross 1. Now, in order to be able to multiply these two matrices, you need 3 something cross 3 here. Now, in the resultant matrix, there are 3 rows, therefore, here it should be 3. Now, if we can find such a matrix, then that is a 3 by 3 matrix. So, in order to get this, sx, x So here we have Sx, and we definitely from the first multiplication we get that. So before that, let's put now 3 cross 3 means there are 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. So here if you put Sx, you get this one. Sx into x, you get this one. In the second one, therefore, you can put zeros. Now, this row by this column, you get this value, Sx into x. Now, Sy into y. So, there are no x terms. Sy into y, therefore here it should be Sy, and now here it should be 0. Now this row by this column, you get this. Now finally you must get 1. Therefore here we have to put no x terms, no y terms, but here 1. So if we multiply this row by this column, you get 1. Now we could find a 3 by 3 matrix. Therefore, S, capital S, simple Sx, simple Sy. We name this matrix. Simple Sx 0 0 0, S simple Sy 0 0 0 1. Now this matrix is called the scaling matrix. Now let's move to rotation. In this situation also let's draw the two axes, x and y. Here we have the origin. So we have a point x comma y. That point rotates around the origin, rotates around the origin in anti-clockwise direction. By an angle of theta. Then we get x1 comma y1. So now let's try to x1 and y1 values using x and y. In order to do that, now this length is r. This length is r. When this point rotates around the origin in anticlockwise order, again this length is also r. Now let's take this angle as alpha. So here we get now this value is x, and if you this value x1, this value y1, now we know consider this triangle. There, this length is x. This length is x, so r cos alpha, that equals r cos alpha. This length is y, so if we consider this triangle, y means r sin alpha. Now if we consider this triangle, so this length is x1, this triangle x1, so r cos theta plus alpha. Then let's expand this r cos theta cos alpha minus sin theta sin alpha. Here r cos alpha, let's put it like this: r cos alpha cos theta, r cos alpha cos theta here, minus r sin alpha sin theta. Now here r cos alpha means x cos theta, minus r sin alpha means y sin theta. So we got this. Therefore let's write it here. x1 means x cos theta minus y sin theta. Now let's try to get y1. So Consider this triangle. Y1 means, then this distance means r sine theta than alpha. If we consider this particular triangle, r sine theta plus alpha. So here we have r sine theta cos alpha plus cos theta sin alpha. Now here r cos alpha sin theta plus r sin alpha cos theta. So here we have r cos alpha, we can put x sin theta, r sin alpha we can put y cos theta. So here now we can write down y x sin theta plus y cos theta. Now we have xy 2 cross 1 coordinates of this point. This one x2, sorry, not x2, here x1 y1 2 cross 1. So now here we have xy 2 cross 1. We have to find the matrix here. Let's say this one means, now x1 means x cos theta minus y sin theta. Y1 means x sin theta plus y cos theta. This is also a 2 cross 1 matrix. So able to multiply something cross 2 type of this matrix must be. In the resultant matrix there are 2 rows, so here we have 2. Now can we find 2 by 2 cross 2 matrix? So here x cos theta. Here we put cos theta, then we get, when we multiply this row by this column, x cos theta. Here minus y sin theta minus sin theta, you get that. X cos theta minus y sin theta, x cos theta minus y sin theta. Now in order to get this term, x sin theta, y cos theta. Now definitely we can find a matrix that can transform this one to this. Anyway, but the problem in the translation. So translation couldn't be transformed. We couldn't find a matrix of type T cross 2 cos 2 for 2 cross 2 for translation. Therefore, we did it using a 3 cross 3 matrix. Therefore, in scaling also we had to find a 3 cross 3 matrix. Therefore, here also we now try to find a 3 cross 3 matrix. Therefore, here it's like this. Here we have x, y, 1, a 3 cos 1 matrix. Now here we have another matrix, and we have to get x1, y1, 1, a 3 cross 1 matrix, and actually this matrix means x cos, here we put the values, x cos theta minus y sin theta. y1 means x sin theta plus y cos theta. Here we have 1. Now in order to get this x cos theta, before that, in order to be able to multiply these two matrices, here it should be something cross 3. Now in the resultant matrix, the number of rows is 3, therefore here we have to put 3. Now it is a 3 by 3 cross 3 matrix. So here x cos theta, therefore here it should be cos theta minus y sin theta, therefore here it should be minus sin theta. That's all. Therefore the last term must be 0. In order to get this one, x sin theta, therefore here it should be sin theta and plus y cos theta, so here it should be cos theta. Now that's all, therefore here it should be 0. Now we have to get here 1, no x terms, here 0, no y terms, here 0, last one we should put 1. Now 0, 0, we are going to get 1. Now this matrix, we write it R of theta cos theta minus sin theta zero sin theta cos theta 0 0 0 1. This is called the rotation matrix. Now those are the 3 transformation matrices we discuss in this video. Hope you could understand well. Thank you for watching.